You guys will practice tomorrow, and we'll review for the quiz Friday, Monday. That's the plan to finish out the year. All right? So this is our last day of new stuff. All right, hope everyone doing well. All right, so let me introduce our topic by saying this. I think many of you guys all take the SATs. No? Some of you didn't because the old covert, the old 19. All right, so some of you may probably, never mind, the SAT might not be a good example. You definitely took some standardized tests in elementary school probably, and when you got the results back, maybe you remember seeing I scored in the 82nd percentile. Okay, you may remember those days. I'm going to show you where that came from today. The 82nd percentile, the 20th percentile, came from this curve I'm showing you up on your screen right now, and that's at the bottom of page 1 of your packet. All right, it's called my normal curve. All right, if you add up all the percents in the curve, it adds up to 100. Here's what I need you to be aware of. The middle of the curve where 0 is, that's where we always put whatever the mean score is. Whatever the average is, we put at 0. Okay, we always put at 0 because if you add all the percents to the left, it's 50%. Add all to the right, it's 50%. How do I calculate the score that's at 1 above the mean? 1 above. That's where your standard deviation comes into play. If you want to find what's the score 1 above, you do the mean plus your standard deviation. We have been kind of doing problems like that lately. All right, so I got my mean score at 0. If you wanted to see the score that's 1 above, you add your standard deviation to your mean. If you want to see the score at 1 below, so at -1, I think many of you could probably guess what I'm going to do to find that score. I'm going to take my mean minus the standard deviation. All right? So that's what you're going to help me do today, and then we're going to add the percentages underneath the curve. All right, so you're going to find me the scores at 0, 1, -1, and maybe further out if we need it, and then add up the percents underneath. All right, let's stop talking about it and let's do it. So take a look at your first example on the next page. First example on the next page. You got measures that follow a bell curve. So can you just box it in, circle the term bell curve? What that means is, hey, use those percents under the curve. If I see the term bell curve, I'm going to use the percents underneath this curve I'm giving you. All right, let's keep reading together. I'll take this one slow. The mean is 80. So where should I put 80 on my curve? Right at 0, halfway. So the score, the mean, 80. Standard deviation of 5. Okay. So if I want to find the score at 1 above, I'm going to add 5 to 80. So the score at 1 above, 85. All right, how about the score at 1 below? Now I won't add 5. I'll subtract 5 from 80. 80 minus 5, the score at -1 is 75. Now let's answer the question. What percent fall between 75 and 80? Well, hey guys, look. It's already labeled, right? You know where 75 is. You know where 80 is. So what's the percent that fall in between? Add them up. Add up the percents from 75 to 80. So right here, these two. And you don't need to make these markings on your curve. I'm just showing you 75 to 80 includes those two percentages. So using my curve, 15.0% plus 19.1%. So how many scores between 75 and 80? Add them up. 34.1% of the scores are between 75 and 80. All right, just by using this bell curve here. And this is what's actually used to rank people when it comes to SATs, ACTs, any kind of standardized test. This is how they rank you. They put the mean in the middle, the standard deviation, they see where your score fell. All right, any questions there before we get to the second one? All right, a set of scores with okay, here's the next term you're going to see. Normal distribution. Circle it, box it in. That term also means use the curve. Normal distribution. Use the curve. All right, let's keep reading. Has a mean of 50. Mean of 50. Standard deviation of 7. All right, so what's my score one above then? 57, yep. And my score at one below? 43. I subtract 7. But you're going to run into a problem. Read the question. Read the question. See if anybody can help me out here. What percent fall within 36 to 64?
I can help.
Okay, why don't you settle down first, and then you can help. Guys, right now, I only have 43 to 57. I don't have 36 to 64, so I need to keep going past 1 and past negative 1. So let's go to 2 now. Let's go all the way out to positive 2. Go ahead, Caroline. How can I figure out the score at positive 2?
Add another 7 and get 64.
Yep, add another 7 to 57 and get, oh, my score at positive 2 is 64. And now subtract another 7 on the left, and you'll find out your score at negative 2 is 36. There's my range I wanted, 36 to 64. All right, so here we go. So everything basically from negative 2 to 2 I'm adding. All the percents from 36 to 64. So if you don't have the range you need, keep adding or subtracting the standard deviation. Ooh, we got a lot here, huh? 4.4 plus 9.2 plus 15 plus 19.1. And you'll see most of the scores, most of them fall within that range. In fact, we have about 95.4% fall in between 36 and 64. It's not that bad, right? These problems aren't that bad. Find out where my numbers are, add them up, no big deal. All right, got some bad news.
It's not going to be there.
I got bad news.
What's that?
Look at the rest of your problems.
They're not there.
What's missing from the rest of your problems? The curve, right? Yeah, I'm never going to provide this curve to you. Okay, so how the heck are we going to know what to add, what percents to add up? All right, I will not give, I'm telling everyone right now, I am not going to provide the curve Tuesday on the quiz or from now on any problem. So how do I do these problems then? On your calculator. Your calculator that you have in front of you right now has a curve built into it. All right, I just got to show you how to use it. All right, guys, so your calculator will be able to do these problems for you, and probably quicker. All right, so let's look at number 4. No curve now, no curve, or number 3, excuse me. Sorry, number 3. No curve here either, we're not using one. Everyone see the scores are normally distributed. All right, so I know I'm going to use my percents here. Mean is 72, standard deviation is 7. Approximately what percent of scores are 65 or higher? So 65 and above, right? 65 and above. All right, go to your calc. I'll write down the steps. If you want to write them down with me, fine. If not, I don't care. All right, we are going into a new button now. We are not going to go to the stat button anymore. Everybody see to the left of the clear button? You have a clear button. To the left, it says bars. And then notice what the wording is above it. DISTR, short for distribution, normal distribution. So that's what I want. Second bars. That's where I go first on the calculator. Second bars. And the only one I ever want to play around with is choice 2. That says normal CDF. All right, so then I will select 2, normal CDF. That's the only place I'm going to do these normal distribution problems. Second vars, choice 2, CDF. I got some stuff in there from last class. Let me clear it out. Or maybe not. Okay, it's not. It's fine. All right, so now we got to put in lower, upper, U, and this little O thing. All of which you have the information for in the problem. Okay, the lower. What is the lowest score in your range now? The lowest score in your range for this problem. You wanted 65 or higher. So what's the lowest number? 65, right? So that's what I'm typing in for lower, 65. That's the lowest score in my range. Here's where I need you to focus in. 65 or higher. We do not know if this test goes up to 100 or not. It could go beyond 100. We don't know. So if that is the case, we don't know where it ends. We're going to type in the highest number the calculator can handle. The biggest number the calculator can handle. And we're going to write it in scientific notation from your old school days. So upper is going to be type in 1. And this is the highest number your calculator can handle. 1. Do you see above your comma button? Above the comma button, you have 2 E's. That's what you want. Second E, 99. That is the highest number your calculator can handle. Basically 1 followed by 99 zeros. All right, that's the highest number your calculator. So that's 65 and above right there. 65 and above we just typed in. All right, next, what does this little U mean? That's the mean. That's the mean of the problem. That's the mean. So that's 72 for us. 72. And then we have seen this little symbol before. This little O. That's your standard deviation. Which the problem gives us, 7. So I type in 7. And then go to paste. And basically what your calculator is doing is taking all these numbers and pasting it into a formula for you. Okay? So you guys noticed your lower, your higher, your mean, and standard deviation all in order. You can press enter. Now let's talk about what the answer is. Everyone's getting this decimal. The calculator gives you the percent as a decimal. Okay? So right now, your calculator is giving you the percent you need, but as a decimal. So if I need the actual percent, what should I be doing with this decimal? Multiplying it by 100. Okay? So everyone make sure you realize that. Your calculator will only give you the percent as a decimal. If you want the percent, you got to multiply it by 100. So about 84% scored 65 or higher. All right, so now we're going to use your normal CDF to do the problems now instead of the curve. Questions from you guys? One doesn't make you great. We got plenty more to do here. Just got to get reps. All right, let's look at 4 now. Yep, 424 junior. Here's the good old SAT exam. I give you the mean was 540, standard deviation of 80. If the scores were, there it is again, right? Normally distributed. That means I'm going to normal CDF if I see that. Sue scored a 740. What percent of students scored below her? Below her. 740 or a below here? What percent of students scored below her? All right, so everyone go to second vars again. Second vars. Choice 2. All right, now everyone think. 740 was her score. I want everything below it. What's our lower now? Or what's our... let me rephrase that. Where's the 740 go? Where am I putting the 7? That's my upper, right? Because it's 740 or below. 740. Now, I don't know where this ends. we're assuming 0, but I'm not going to put in 0. I'm going to put in the smallest number the calculator recognizes. The smallest number. Everyone remember the 1e to the 99? Just change it to negative 1e to the 99 now. All right, negative 1 followed by 99 zeros. So negative 1, the e, which is above your comma again, 99. All right, so that's the lowest you can go. So right now we're doing 740 and below. Type in your mean. What was our mean? 540 with a standard deviation of 80. So 540 your mean, 80. Everyone's all right? Because I'm going to start calling on numbers next problem for you guys to tell me what to plug in. Paste. Now, everybody stop here. Notice number 4 is not multiple choice, but I'm still going to require work. I just don't want to see an answer and that's it. I need to see work. So how do you show work at a problem like this? See what's on your screen right now, on my screen in your calculator? That's what you write down for me. That's your work. Here you go. Here's your work for problem number 4, since it's not multiple choice. Normal, CDF, and then what the numbers are for you. You're just writing what's on your calculator screen. Negative 1E99, comma 740, comma 540, comma 80. That's your work for a non-multiple choice question. All right. And then, okay, let's figure out what the answer is. It says to the nearest percent. Enter. All right, that's a percent as a decimal. Multiply it by 100. Nearest percent, so about 99%. In other words, Sue is a stud. 99% of people scored below her. Woo. Showing off. Questions on calculator use before I start calling on you guys? All right, let's do it. Let's get through these last couple. The amount of soda in a can, oh, there it is, normally distributed. Normal CDF. I'm going to keep writing it, you don't, but. Mean of 12, good. 250 soda cans were pulled. How many would you expect to be less than 11.1? All right, everyone see our range? Less than 11.1. Less than 11.1. All right, let's do it. Let me start calling on kids. Let me get the second bars, number 2. Can you guys help me out? What's going to be the lower and the upper here? The lower and the upper if my range is less than 11.1. That's my first question. What's your range? Less than 11.1. What's my lower and my upper going to be? First up is Will. Here you go, Will. What should be my lower and my upper? Less than 11.1. Let's start with the lower, Will. What should it be, my lower?
The negative 1e.
You got it. You got it, boss. Thank you. And what about my upper?
The 11.1.
Great job, Will. Good find. God, fat fingers. 11.1. Got it. And now I'm not even going to ask. You guys can read. You pick off the mean and the standard deviation, which would be 12 for the mean. Standard deviation, 0.6. Paste it. Now this is multiple choice, so I don't need to see it written down. There is your percent as a decimal. But I don't know how many of you guys are reading this problem carefully. I'm not looking for the percent here. Look, read the problem. How many are expected? Everyone, there are 250 soda cans. How many of them are going to be less than 11.1? Well, I know about 6% of them are going to be below. So what can I do with this number I just found in my calculator? And the 250. If I want to find out how many cans are below 11.1 ounces, I'm going to multiply them, yeah. I'll take my percentage I just found in the calculator and multiply it by how many cans I have, 250. All right, so let me show that here. So I'm going to take my number, 250, 250 cans times the percent as a decimal, gives me about, what was it, 17? 17 cans. Be careful. Not all the questions I ask will be what percent. All right? All right, let's try 6 out together. Somebody be ready here. Before we answer 6, you will not see normally distributed anywhere. You don't see normally distributed, but I do see this. Any standardized test, always normally distributed. So SAT, standardized test, normal CDF is going to come into play. All right, here we go. Let's go back to the second vars, number 2. Okay, can I give you the range here, right? What percent of scores fall between 76 and 90? What do you want me to plug in? Mason, what do you want me to plug in for my lower one here?
76.
Yep, and how about upper?
90.
There you go. And then you guys can take the mean and the standard deviation right from the problem. Make sure after you hit paste, that's the work you're going to show. All right, because this is not multiple choice. So please write that down because that counts as your work. Okay, what do I got? All right, there it is as a decimal. The answer says to the nearest percent. So let's multiply that by 100. About 90, was it nearest percent? Yep, nearest percent. So 95% are between 76 and 90. Questions from you guys? I'll let you guys finish that up, writing that in. And I'll make a deal with you. We'll do 7, and then we'll wait for it to do number 8 for a review for the quiz. All right, I'll stop on number 7 because I know I've been grinding away at you guys. So we'll stop at 7, and we'll leave 8 for a quiz review. All right, here we go, 7. Test scores on a test, normal distribution. All right, there's normal distribution. We know where we're going in the calc. What percent of students receive the score greater than 90? Watch out now, greater than 90. Second vars. Greater than 90. What do you want me to plug into the lower then? Greater than 90. What's going into the lower? Nick, what's going into the lower, Nick?
90.
90? What's going into the upper?
1E99.
Good job. Way to remember that. 1E99. Biggest number I could find. I don't assume the test goes up to 100. And then go ahead, guys, type in your mean of 72. Your standard deviation of 9. Paste. Show your work. And it says approximately, I'm going to tell you nearest tenth of a percent. Let's go tenth of a percent here. Nearest tenth of a percent. Remember to multiply it by 100 to get it into percent form. So about 2.3. Make sure you get out 2.3 after you multiply by 100. And then we'll save number 8 for quiz review Friday and Monday. Wow. I don't know how to feel right now. That's it. That's the last new stuff I got for you. It's been real. It's been good. Hasn't been real good. Have a great day, everyone. I'll see you tomorrow for the assignment. Take care. What are we looking at for the 10? 81 feels like 86.
What, for the weather?
Could be worse, I guess. 75% humidity. It was up in the high 90s yesterday.
Could be better
Hopefully they say this is it today.
for the humidity.
Yep. We're back to the mid 70s tomorrow.
There's something about the mid 70s that's so nice. Or is this too hot? A good one. See you
So-
later.
A lot of the lights in the classes that have been off today. Weird. What likes more energy? More energy equals more heat. Oh, and there's a better.
Unless you stack your lineup like
I did it.
this.